All right, we're looking at chapter 3 review. Number 1, 81 to the negative 2/3. So the negative exponent, of course, tells us that we need to flip. And so now I need to look at simplifying 81 to the 2/3. So I'm going to change the form. So that would be cubed root squared. So now the cubed root of 81, if you think about your perfect cubes, can break down 27 and 3. So I'm going to come over here. So I'd have 1 over the cubed root of 27 times the cubed root of 3. And this has still got an exponent of 2 on the outside, okay? So I end up with 1 over, the cubed root of 27 is 3, the cubed root of 3, and this is still squared. So I have 1 over, the squared goes to both pieces here, so I'd have 1 over 9 times the cubed root of 3 squared, which is 9. Number 2, just keep this separated here. Number 2, ask for the cubed root of 8 to the negative 2. Again, that negative exponent is going to cause us to flip. And the cubed root of 8 is 2. And 2 to the second power is 4. Okay, moving right along. Number 3. Now this is one that probably looks a little intimidating at first. So first thing I want to do is look at what's the same. So I see the 64s up top, and I know that when I have the same base I can combine the exponents, right? So I get 64, 5 over 9 plus 2 over 9 is 7 over 9. And then I have 4 to the 3/9. So now the question is, we know that when we're multiplying or dividing, if the bases are the same, I can combine the exponents. And then if the exponents are the same, of course, I can simplify the bases. But in this case, neither one's the same. So I have to say, well, is there some way that I could rewrite either one of these, either the 2 exponents or the 2 bases, so that they're the same? And the answer to that is yes, there is a way. And in fact, 4 to the 3rd is actually 64, right? So I could change the way 64 looks by making it a base of 4. And so what happens is I end up with 4 to the 3rd, okay? Remember, it's still got to have the value of 64. That can't change, but I can change the way it looks. So I have 4 to the 3rd. It's still raised to the 7/9, and I have 4 to the 3 over 9 on the bottom. So now by my exponent properties, I know that if I raise an exponent to an exponent, then I multiply. So I have 4 to the 21 over 9 divided by 4 to the 3 over 9. Now if you notice, my bases are exactly the same, so I can subtract those exponents. 21 over 9 minus 3 over 9 is in fact 18 over 9, and 18 divided by 9 is 2, and 4 to the second power is 16. Okay? Number 4. This is another one that as I look, I notice right off that nothing's the same, but let's go ahead and handle these exponents and see what happens. I can distribute this exponent top and bottom here. So I get 363. 3 times 1 over 6 would be 3 over 6, which is the same thing as 1/2. And then 3 times 1 over 12 would be 3 over 12, which is 1 over 4. So now the question becomes again, can I rewrite 363 and or 9 to have the same base? No, I can write 9 as 3 squared, but 363 is not a power of 3. So there's really nothing that I can do here to rewrite. But I do notice this 1/2 and this 1/4, right? Those are very closely related, because if you think about it, 1/4 is the same thing as 1/2 times 1/2, right? I can rewrite 1/4 as 1/2 times 1/2. So if I were to do that, I would end up with 363 to the 1/2, 9 if I want to multiply them, then I write it this way, right? And this is helpful because now I have these 1/2 on the outside, right? And now they're both the same. All right. So, conveniently enough, 9 to the 1/2. Remember, anything to the 1/2 is the same thing as a square root, right? So, 9 to the 1/2 is 3. So I get 363 to the 1/2 over 3 to the 1/2. Now, because the exponents are the same, I can combine these bases. So 363 divides by 321 times to the 1/2. Again, 1/2 is a square root, and we know that the square root of 121 is 11. Okay? So manipulating those exponents a bit, whereas in the one before we manipulated the bases a bit. Okay? All right, let's keep moving along. Number 5 asks us to solve here. So what we're going to do is since we have two radicals, we're going to get them on either side. They're already on either side. So I am going to square both sides. Okay? That cancels out my radicals, and it leaves me with 7x minus 7 equals 3x minus 2. And now this is a simple solve. I'm going to gather my x's together. I'm going to subtract 3x from both sides. I get 4x minus 7 equals negative 2. Add the 7. 4x equals 5, and I'm out of room here. So if 4x equals 5 and I solve for x, then I find out that x equals 5 over 4. Okay? Number 6, again, now this time I have one radical instead of two. It's already isolated on a side by itself, so I'm going to go ahead and square to take care of that. Now, when I square the last side, remember this minus sign is going to cause me to have to multiply this out. So this would be x minus 4, x minus 4, and then I have 8x minus 48. Okay, I'm going to multiply out the left side. So I get x squared minus 4x plus 16 equals 8x minus 48. So this leaves me with x squared minus 8x plus 16 equals 8x minus 48. I want to get everything on the same side because I do have a quadratic here, so I want to make it equal 0. So I subtract 8x and add 48. X and add 48, and I am going to come right up here to finish this problem. So that gives me x squared minus 16x plus 64 equals 0. Okay, I still have to solve. The whole goal was to solve for x to find out what x equals. This is in fact a perfect squared trinomial. Square root of x times the square root of 64 would be 8x, and doubled is 16x, so it factors as x minus 8 squared equals 0, which then means that my solution is x equals 8. Last one on this first page is the 5th root of 4x to the 8th minus 2. Again, one radical, it's already isolated. So I will just go ahead and eliminate it by raising both sides to the 5th power. So now I'm left with 4x minus 8 equals, and 2 to the 5th power would be 32. Add 8 to both sides. And divide by 4. Alright, so number 8, we are just multiplying two polynomials here. So we have f of x, which is 5x to the third minus 3x squared, and to that we are going to multiply 2x squared. So I want to distribute this 2x squared through, or whichever way you want to look at it. So 5x cubed times 2x squared, remember multiply the coefficients and add the exponents, so I get 10x to the fifth. And then the second one would be minus 6x to the fourth. Again, multiplying coefficients and adding exponents. Number 9 is a composition. So I have f of g of x is 2x squared. So I want to take f, replace every x with 2x squared. So I get 5 times 2x squared to the third, because it's 5x to the third, minus 3, it's not x, it's 2x squared, okay? Because I'm multiplying inside these parentheses, I can distribute this exponent through both of these, so I end up with 5 times 2 to the third is 8. This x squared to the third becomes x to the sixth. And then I have 2 to the second, which is 4. X, and 2 times 2 is 4. Okay? Combining these coefficients here together, I would have 5 times 8 is 40 minus 12x to the fourth. And that's all you can do. All right, for number 10, I am verifying inverses, which means that I'm showing two things. I'm showing that f of g of x will simplify to x, and I also need to show that g of f of x will simplify to x as well. Okay, so I've got to show it both ways. All right, so forwards f of g of x. So I'm doing f of g of x is cubed root of x over 6. So I take f, which is 6 times the cubed root of x over 6 to the third power. The cubes and the cube root cancel because exponents come first, so I'm left with 6 times x over 6. The 6's here cancel, and it does in fact simplify to x, but that's only half the problem. Now I need to do g of f of x. So g of 6x to the third. So I have the cubed root of 6x to the third over 6. And I need to simplify down some, so I'll mark the 6's out. And now the cubed root and the cubed would just leave me with the x. Okay, so it does verify both forwards and backwards, so I have verified that f and g are in fact inverses. Let's move on to number 11. Again, f of g of x and g of f of x. So f of g of x would be f of 3x plus 6 over 2. So 2 times 3x plus 6 over 2 minus 6 over 3. The 2's, in fact, cancel first. I need to do whatever I can in the top of the fraction and then the bottom of the fraction, because that kind of groups things together. Leaves me with 3x plus 6 minus 6 over 3. The 6's are next, and I'm left with 3x over 3, and of course the 3's at that point cancel and leave me with the x. All right, let's go the other direction and let's do the g of f of x. So g of 2x minus 6 over 3. So I have g is 3x plus 6 over 2, so 3 times, not x, but 2x minus 6 over 3. Plus 6, everybody goes over 2. 3's cancel first, leaves me with 2x minus 6 plus 6. Oh, I forgot that's over 2. So this leaves me then with 2x over 2, and of course the 2's cancel at this point, and it leaves me with x. Moving right along then to number 12. Find the inverse of the function. So of course remember f of x is the same thing as y. So if this was y, I'm going to switch x and y and just run through the process of solving this for y. So the first thing I want to do is get rid of that fraction, so I'll multiply by the reciprocal. Okay, so I have negative 8 over 3x equals y to the 7th. Okay, so then I do the 7th root to get rid of that exponent. And so I end up with the 7th root of negative 8/3 x. And this is the inverse of x. Okay? Number 13, again, switch that x and y. And we are going sad map here. Okay? First thing I want to do is subtract the 4 from both sides. Order is the most important part here because you got to remember that you're going in the order in which we solve. So next I do the multiplication, so I'll multiply by 2/3 to cancel out that fraction. So I have 2/3 times x minus 4 equals y to the 3rd. And again, to get rid of that third power, I am going to do the 3rd root. So the inverse here is the 3rd root of 2/3 x minus 4. Number 14, again switching x and y, so x equals 2y to the 3rd plus 3 over 7. I'm going to multiply both sides by 7. Okay, so now I have 7x equals 2y cubed plus 3. I'm going to subtract the 3 from both sides. So I have 7x minus 3 equals 2y cubed. This one has an extra step in here. Divide by 2 on both sides. So 7x minus 3 over 2 equals y to the 3rd. And again, that cubed root will take care of that exponent. And so the inverse of this, the inverse is the cubed root of 7x minus 3 over 2. Sorry, I'm running out of room here. Number 15. Number 15 is neat because it kind of combines, you have to think about some exponent properties as well as some radical properties. With the numbers here, I'm going to do the square root of 18 and the square root of 49. And I am going to change, I'm going to simplify these fractions just a little bit. 5x's up top and 1 in the bottom would leave me with 4x's up top. I have y to the 4th and I have z to the 3rd. I'm going to change, whereas it did have a square root, and I'll show you. It's got a square root here. What I'm going to do actually is I'm going to change that square root to an exponent of 1/2, and I'll show you why. It'll make a little more sense. Square root of 18 I'm going to break up. Remember, square root of 18, I could do the square root of 9 and the square root of 2, which would be 3 times the square root of 2, right? So I'm going to do 3 square root 2 over, and I have a 7 here, right? If I change this radical, use a little bit of a contrasting color here so you can see, to an exponent of 1/2, what happens is I can take this exponent to everything, right? So I end up 1/2 times 4 is 2. 4 times 1/2 again is 2. And then I have z to the 3 over 2. And we could rationalize this denominator at this point to get the square root out of the bottom, but I think we'll hold off for right now on that. All right, number 16, the cubed root of 80. So again, I'm looking for a power of 3 that I can take out, in which case that would be 8 and 10. The cubed root of 8 is 2. Cubed root of 10 stays. Okay. Flipping over for the last two, the square root of x plus 6. For this one, my starting point here would be -6, -3. Now I need that direction point. So I'm going to use -5 because I'm going to just go one beside it. And that would give me the square root of -5 plus 6 minus 3. Which would leave me with -2. Okay, so there's my graph. I do need the domain and range here. The domain goes from this starting point, remember, is -6, -3. So the domain goes from -6 to infinity, whereas the range goes from -3 to infinity. Last one, yay! My cubic, so I need 3 points. My start point here, I'm missing the h, so it's going to be 0, 8. I need 2 direction points, so I'm going to use 1 and -1. I'm going to go on either side there of the start point. When x is 1, y is cubed root of 1 plus 8, which is 1 plus 8, which is 9. When the x is -1, then y is cubed root of -1 plus 8, which is -1 plus 8, which is 7. So here my domain again, because it's a cubic, is -infinity, infinity, and the range is -infinity to infinity.